Welcome to Breadboarding. In the previous video, for which will be links at the top here if you missed it, we covered resistors and how to work out what the values were. We also looked at capacitors as well, and we also saw what happens when you incorrectly fit tantalum capacitors the wrong way round. So this caught fire and generated lots of smoke. So this is the fourth video in the how to use breadboards and retro digital electronics, and in this video we're going to be wiring up our 555 LED flasher circuit. So we'll just go back to our circuit diagram just to remind ourselves what we're going to be doing now. So we're going to be plugging in the 555 timer. We actually need a 1 microfarad capacitor, the LED and our 330 ohm resistor, 220k resistor and a 1k resistor, and this 0.01 microfarad capacitor is just to stabilize the outputs from this and get interference otherwise. And the values that we got here, 1k, 220 kilo ohms, 1 microfarad, should give us a 3 hertz 0.3 seconds period. Okay, so I'm going to use one of these white breadboards. It'll just be a little bit easier to see things on here. Now, in order to wire these things up, you can use these sort of jump wire kits. However, I prefer to make my own. Certainly when you're doing more complex circuits, it's easier. So what I tend to do is to use this sort of solid core cable. So it's important that you get solid core cable, and it's 22 AWG, American wire gauge. I'm not entirely sure exactly what size that is in metric, but if you get sort of these sorts of packs, they include a number of reels in there. The only problem I run into is I seem to use a lot more blue than I do of all the other colours, so I tend to run out of blue first. This sort of solid core cable is great for actually wiring these things up, and this is pretty much what Ben Eater recommends as well. You're also going to need certainly a pair of cutters, wire cutters, preferably one which has a flat end on one end, a flat side on one side. So some wire cutters, they'll be sort of like angled in both sides. Makes it a lot easier to actually cut certain components and things when they are flat on one side. Certainly a small pair of pliers is useful. This is a very old pair that I've got from a long time ago. I haven't been able to find anywhere to buy something similar. I also tend to use a pair which have serrated jaws there, so that makes it a bit easier to grip slippery components. You almost certainly will need some form of wire strippers. Now I know Ben Eater tends to use this style of wire stripper, and I'll show you how to use that in a minute. After a period of time, you'll probably want one of these. Now, this one I was able to buy for about £4 a long time ago. I looked on Amazon, and that original supplier doesn't sell these anymore, but you can buy something very similar or identical, apart from the fact that it has a brand name on here and now costs 5 times as much. But you can get these type of wire strippers, and I'll show you using these in a few minutes. Certainly, if you're going to do anything more than a couple of breadboards at a time, you're probably going to need to get one of these things at some point in time. But for small circuits, you can certainly make do with one of these. These are our 555 timer chips. Again, these ones I think are from Bitsbox. Now, one of the problems with when you get chips new, you just zoom in. So the two chips here, the one on the left I've previously used, but the one on the right is brand new. And if we just take it out, and if you look at it, it's a bit difficult to see here. The pins will be slightly splayed out, and they'll be splayed out such they won't easily fit into the breadboard. So if we just change it around, put it on those bits of card, and if we compare them, you should hopefully be able to see that one of them is more splayed out than the other. Now, you can use a pair of pliers to bend these in, but the easiest way to do it generally, but it's a little fiddly with these 8-pin ones, is just to hold the chip at both sides and just push gently and evenly down to bend the pins slightly in. It only needs to be about half a millimetre or so. Then turn it over and do the other side. And then hopefully the pins on your chip will then plug into the breadboard okay. So these are 8-pin ones are slightly fiddly. Just need to make sure we got it the right way around. So in fact, if we put it under the microscope, we'll just have a look at how we tell which way around the chip is. So you can see there that there's a spot on the top of it, and if we just change the lighting, we might be able to pick up the lettering on it. not very easily. So if you angle the light on it, you can see that it's an NE555. But generally, when you have chips, then they'll either have a little dimple at the top and the middle of the chip, or they'll have a dot on the near pin 1. So that tells us which way round it needs to go into the circuit. If we just check to see if this one will fit, just check that fits okay. Yeah, the pins seem to be in. I haven't pushed it in yet, but I'll just clear away a bit of stuff here. Now, I showed in one of the earlier videos using chip labels, and I've used this on all the projects so far. And these little chip labels, we're just going to cut that out and use a glue stick to stick it onto the chip. It just helps to prevent us from making mistakes when wiring up the chips. Just cut that out and then use a glue stick, a Pritt stick as we call them in the UK, and just going to stick the label on. Generally, when you put it on, you can move it around a bit and look at it from on top just to make sure that the label's directly over the pins. And we'll push the chip in a minute once we've got it in the right place. Just move it down and plug it in. First of all, what we want to do is to wire up the power rails. So I always try and do the power rails first, because if you omit the power, then it can result in confusing time, as I have experienced a few times. And in order to do this, the easiest way how to make the little red lead and black leads that we need. So we need a black lead that goes from here to here and a red lead that goes from here to here. Sometimes you'll find when you need a ground lead that goes from here to here, it's an extra hole longer that we need. But for the moment, we've just got these holes here. Now, this is a ruler with tenths of an inch on it. And if we actually measure what the distance is from one hole, from the hole on the plus side there, that is about 3/10 of an inch. So these things generally are going to be generally in inches, because the spacing between all of the pins is 1/10 of an inch, which is 2.54 millimeters. So it's easier to do things in tenths of an inch. So just going to cut off a bit of wire at a 45-degree angle. Measure 1/2 inch. Strip the insulation off. A good pull. This wire's a fair bit tougher than the previous one I've used. And then we need to measure 3 holes in, a third of the 3/10 of an inch in, so that's up to there. And then we'll just cut that at an angle as well. And normally the insulation on here, if you give it a bit of a twizzle, rotate it, and you can actually then move it along. And then when you've got about an even amount either side, and then just bend it in, and then, and hopefully we've got the right size link going here. If that's a faff, it is. So what I tend to do when making these sort of little short jumpers, I cut off a bit of wire here. I'll use the wire strippers like this, and they're set at 1/2 inch here. Just strip that off. Then what I've done, I made in an earlier videos, in the early series, I've made this sort of little jig here, and if you push this in here, this is long enough for 3 holes. Just cut it here and just now we can bend this, and it's a lot quicker. Okay, so that's made ourselves a 3-hole black connector there. That's our ground. So using a jig like this, if you actually cut out 5 bits or 10 bits at a time, stick them in there and do this, then you can actually make up quite a number of these things fairly easily. So we've done that one and that one. We also need to tie reset to 5 volts as well. So we'll just wire up that one. And then we'll also then put our capacitor between the pin 2 and ground as well. For our capacitor, you can see that the negative side is on the white thing, 1 microfarad. That is going on pin 2, the ground. And in fact, what we can do is just wire this in to the ground rail that's in above it. Now we need to wire in the LED and the 330 ohm resistor onto pin 3. This is our 330 ohm resistor, so you can see that that is, if we put it this way, orange, orange, brown, and then the gold band means it's 5%. Now, for the moment, I'm going to plug this in from pin 3, and because the resistor is a little bit long, then what we're going to do then is then take our LED. So if you remember, the long lead is the anode that goes to the plus voltage. I'm just going to plug that in for now. And then we'll tie the cathode, that was the short one, to ground or 0 volts. Now when you're first wiring up a circuit, quite often you'll have all the leads a bit long and straggly, and then you might go back and tidy it up. So what I'm going to do here for the moment is tying pin 2. Look here, pin 2 goes round to pin 6. So to do that, I'm just going to use a jump cable. You get a pack of jumpers like this for a couple of pounds or so, and what we can do to start with is we just plug in between pin 2 and pin 6. Now we need to do this capacitor, the 1K resistor, to pin 7, and then we'll do this one a little bit later. So here's the 0.01 microfarad or 10 nanofarads. So in fact, this has got 103 on it. So if you remember on the slides we were looking at, that would actually be 10,000 picofarads or 10 nanofarads. That needs to go to ground. Then we've got our 1 kilo ohm resistor that needs to go from 5 volts to discharge pin 7. At the moment I'm leaving all the leads nice and long, and what we'll do in a bit is tidy it all up and make it look a bit neater once we've got it working. Now we need to do the 220k resistor between pin 6 and pin 7. In fact, here we can actually just fit this between the two like this. The only thing I'd say, when you've got the long leads like this, it does make plugging the components in a little bit more difficult. You can see here that this is in actual fact red, red, yellow. That's 220 kilo ohms. That's our circuit wired up. If I plug in the power supply. Okay, so that's all plugged in. The power supply is turned on, so we'll just switch on the power supply, and we have a flashing LED. Great. So our very simple circuit works. Now the reason why we need to get this timer working is because there's easier ways of flashing LEDs, but we need the output here to feed into some of the circuits we're going to be playing with our logic gates in upcoming videos. And in fact, just to prove a point, you can actually now buy flashing LEDs, so you don't actually need any of this circuitry. So I'll just plug in these flashing LEDs and we'll just compare them and see whether or not you'd want to use these as a replacement for this circuit here. We've got two LEDs with the anode is the long lead and the cathode is the short one. So what I'm going to do is to wire in one ground connection there, and then we'll plug in both the LEDs to the same ground connection. And then I've got two 300 ohm resistors. We'll just plug those in. Okay, so these are two flashing LEDs wired up. We'll power this on and see what happens. Okay, so you can see they're flashing a slightly different frequency from the one we've got here. And what you might notice is that over a period of time, the two LEDs actually flash at slightly different frequencies. So you can see that in fact that now they're almost blinking alternately. They're now blinking alternately, and then they will come back in phase again over about half a minute or so. So in fact, there's no way with these flashing LEDs for you to control how fast they flash. Okay, so we finished the first cut of our LED flasher. In the next video, we'll look at tidying this up, and we'll also look at using one of these analog 555 versions. So this is actually a little PCB that emulates what the 555 does. So we'll have a look at that, and we'll look at some of the signals that generates. So if you don't want to miss out on future videos, then please hit subscribe, and if you could hit like as well, it just helps to make the videos available to more people. Thanks for watching.